TCP IP model. If I will talk about the new TCP IP model, so we have only four
Four.
layer.
Yeah.
Yes. May I know the name of those four layer?
Application,
Application,
transport,
application layer.
network, and then data link and physical come together.
After that, internet layer. Application, again transport,
Okay. Yeah,
transport,
transport.
and then internet.
Oh, not network, right?
Yes, internet layer.
Okay, gotcha.
Internet layer is similar like your network layer. Transport
Network
layer
layer.
is like transport layer. And then
Uh,
we have network interface layer.
okay.
Network interface, we can say. Network interface is similar like,
Data link and physical.
yes. So these are a few reasons why we are using, TCP IP model instead of using OSI model.
Mm-hmm.
Because OSI is an practical model, and TCP IP is an practical model, and OSI model is an reference model. It is not a practical. And TCP IP model is similar, simpler than OSI model as well. As you can see, we have less layer, which make easier to understand and implement. Because OSI model have 7 layer, that is complex as compared to TCP IP model. Yes or no?
Yes.
Okay, so sometime interviewer or anyone can ask you the reason as well, that why we are using TCP IP model over OSI model, and real time we are using TCP IP model. Done. Can I move?
Yes.
Okay.
Could you please write it in notes, please?
This one,
Yes. Why we use TCP model over
TCP
OSI?
OSI. See, first point is OSI model is an a reference model, conceptual model, and TCP IP model is an practical model. TCP IP model is simpler than OSI model. We have only 4 layer in TCP IP model, we have 7 layer in OSI model. So it is easier to understand and implement.
Mhm.
So these are the reason. Any 2 reason or 3 reason you can mention anywhere if someone will ask you the question, this question. Okay.
Okay. Okay.
Here TCP IP model show more common term and layers used when people talk about the TCP IP today. The bottom layer focus on how transmit bits over each individual link. The data link layer focus on sending data over type of physical link. For instance, network. So you can read these are simple things. Here are some protocol of application layer like HTTP. Can anyone tell me HTTP protocol you use which service at transport layer? At transport
Uh,
layer we have only two services, TCP and UDP.
We can use in TCP.
TCP. Can
Yes.
can you tell me what is the difference between TCP and UDP?
So,
UDP, TCP is more secure.
No, no, no,
Uh,
no, no. Sorry.
so
There is
TCP
no
is,
relation of security between TCP
yeah,
and UDP.
TCP
it's
is
for
used for video, like for the video stuff, like we can use
UDP.
video. UDP used for
UDP. Yeah, used for big data, for transfer big data.
UDP used for the fast communication,
Yeah.
and TCP is an slow communication. TCP is an connection oriented, UDP is an connection less. TCP is reliable and UDP is unreliable. In my notes also I have mentioned this point, so that's why I am not making the note of it, because see here
yeah,
I have mentioned very clearly this thing.
yeah. I see everything.
Yes or no?
Yes.
Here is difference. TCP is a connection oriented, connection less. Connection oriented means three-way handshake.
Yes.
What is the purpose of three-way handshake?
Mm.
To send data securely to other hosts.
You see, if I am building a connection between a sender and receiver devices, there should be a reason. There should be definitely a reason, because we are building a logical connection before sending the actual data. The reason is, actually we are checking that server is available or not first. In TCP is reliable. So we are checking that my server is available or not. My server is able to give acknowledgement or not. And we are negotiating the MSS, maximum segment size. What should be the size of one segment? After that, we can arrange receiving data in the sequence. We have sequencing in TCP. We don't have sequencing in UDP. Data retransmission can be possible in TCP, but data retransmission is not possible in case of UDP. It is unreliable. TCP is unreliable. UDP is an unreliable protocol. Flow control can be achieved over here, but flow control cannot be achieved. Windowing is used in TCP. Windowing is not used in UDP. These are the difference. If I will talk about the header size, so header size of TCP is 20 byte. Header size of UDP is 8 byte. TCP 20 byte, UDP 8 byte. This is also advantage of UDP. UDP header size is less. After that, we have some protocols which uses TCP at transport layer, that is HTTP, HTTPS, Telnet, SSH, etc. These are the protocol which uses TCP at transport layer. And DHCP, NTP, DNS, these are the protocol which uses UDP at transport layer. Done. You already know what is the meaning of connection oriented three-way handshake. This is sequencing. You know how sequencing works. See here. Like I have one computer over here and I have one server over here, let's say. IP address of, let's say, this machine is 10.1.1.1 and IP address of this server is, let's say, 10.1.1.2. Right? This is my, let's say, HTTP server. HTTP S server. Done. So from this PC, if you want to access HTTP services on the server, what you need to do? Application in the browser, you will type what www. Let's say this is www.google.com. Google.com. So here in the browser of PC, you will type what? www.google.com and you will hit enter. Once you will hit enter at application layer, this machine will generate one HTTP data. At which layer? At application layer, HTTP data. This machine will generate one HTTP request. At which layer? At application layer. After that, as you know, we are using TCP IP model. Directly application layer will hand over it to transport layer. Yes or no?
Yes.
Transport layer will do what? Transport layer will add one header. Which header? TCP header or UDP header?
TCP.
TCP header, because HTTP uses TCP. And in TCP header, there will be information about source port and destination port. Source port will be what? Source port will be random port number. As you know,
No.
there are two types of port number.
Yeah. Source port will be noun and
Source port will be the unknown, random, and destination port will be the noun, port number of HTTP.
Mhm.
There are two types of port number, well known and unknown. Well known port number are those port number which we already defined to protocol, and unknown port number are those port number which are free. which we have not defined to any protocol. So here source port will be the random from the range 1024, let's say, and destination port will be 443. This is the port number of HTTPS, or let's say I am using HTTP, so 80. Done. At transport layer add source port and destination port. Yes or no?
Yes.
After that, it will hand over it to next layer, that is network layer. At network layer, IP protocol is responsible to add IP header. In IP header, there will be information about source IP, destination IP, and protocol field. Right? Source IP will be what? 10.1.1.1. Destination IP will be what? 10.1.1.2. And protocol field will be what? Protocol number will be the protocol number of TCP. That is 6. 6 is the protocol number of TCP. Means upper layer protocol who have hand over this actual traffic to IP protocol. Done.
Yes.
After that, network layer will hand over it to data link layer. Data link layer will add one Ethernet header, because here we are using Ethernet cable to connect devices. And Ethernet header at data link layer, Ethernet header will add source MAC and destination MAC. Source MAC will be, let's say MAC address of PC1 is A, and destination MAC is MAC address of, let's say, server is B. After that, there will be one field called type field. In type field, there will be information about upper layer protocol. So upper layer protocol is IPv4. So there will be type code of IPv4. IPv4 type code is 0x0800. Getting my point, guys?
Yes.
And then it will hand over to next layer. See, at application layer, we call data to data. At transport layer, we call data to segment. Segment means what? Your actual information plus transport layer header. Transport layer header can be TCP header or it can be UDP header. After that, at network layer, we call data to packet. Packet means again actual information plus IP header. And at layer 2, at data link layer, we call data to frame. So frame means actual data plus Ethernet header. After that, it will hand over to physical layer, and physical layer will transmit it on link. Done. Done, guys?
Yes.
Yes.
So server will receive this data at which layer? Physical layer. Physical layer will convert data into frame, and it will hand over to next layer, data link layer. Data link layer will check the first destination MAC address. Destination MAC address is B. If destination MAC address is the MAC address of server or broadcast, then only server will accept the data. Otherwise, it will discard the data. Done?
Yes.
So destination MAC is the MAC address of server. It will accept and it will check the next field, that is type field. In type field, there is information about IPv4. So it will hand over data to IPv4. It will remove layer 2 header and it will hand over actual packet to network layer. Network layer will open packet. In packet, there are two things: segment plus IP header. In IP header, it is going to check the IP address, destination IP address. If destination IP address is broadcast and the IP address of server, then only it will accept, otherwise it will discard. So if destination is IP address of server, it is going to check the protocol field. In protocol field, value is 6, and 6 is the protocol number of TCP. So IP protocol will hand over it to TCP protocol. TCP protocol will check destination port number. If destination port number is enabled on server, that means this service is enabled, then it is directly going to hand over the data to HTTP. Otherwise, if this service is not enabled, it will discard the data at transport layer. Done?
Yes.
Is it clear? So
Yes.
see, while sending, when PC is generating data and sending data, what PC is doing? PC is adding extra information, yes or no, at each layer.
Yes.
So adding extra information with actual data is known as encapsulation. Right? Encapsulation means adding extra information with actual data. And server receiver machine will do what? It will remove the each extra information at each layer. It will remove all extra information at each layer, and it will pick the actual data and it will hand over to the HTTP protocol. So removing extra information from the actual data is known as decapsulation. Done? So are you
Yep.
clear with these two terms, encapsulation and decapsulation?
Yes.
Yes.
1 second, guys. So in your book also you can read these things. See, this is server and this is PC. PC is sending one request, give me your web page, and then server is giving, here is your web page. But before it will perform three-way handshake. HTTP protocol, like HTTP protocol, you can read here about HTTP protocol, about all application layer protocol. That means important application layer protocols you need to learn. And sequence number. See how sequence number is working. Computer, server. First of all, see how sequence number and acknowledgement will work in case of three-way handshake. This is my PC. This is server. Done. First of all, here suppose this PC want to send one HTTP data. So HTTP is an TCP based. So first of all, it will send one SYN message to server. SYN message is nothing but your TCP header. Okay. In SYN message, it will send sequence number. Sequence number will be, sequence number is equal to 0, and it will send the acknowledgement number. Acknowledgement number will be also 0. Right? This is SYN message. After that, server will generate what? SYN plus ACK. Server will send SYN plus ACK message. SYN plus ACK. In SYN plus ACK message, sequence number will be 0 because it is sending their, server is sending their first message. So sequence number will be 0, and acknowledgement number will be sequence number plus 1. So in the first packet, it have received first packet SYN message from the PC with sequence number 0. So it will give acknowledgement on acknowledgement number 1. Done. Acknowledgement is sequence number plus 1. Okay, when PC will send next message, that is acknowledgement message. In the acknowledgement message, this is ACK message. Acknowledgement. Here sequence number will be 1 because it is second message. Sequence number is 1, and it will give acknowledgement as well.
1.
This is acknowledgement. So acknowledgement will be what? 1.
1.
Acknowledgement. So this is how sequence number and acknowledgement number work in case of three-way handshake. Done. Now see how sequence number and acknowledgement number work in case of sending actual data. Computer and server. Let's say this computer have sent one data to this server, and here sequence number is anything. Sequence number is, let's say, 100, right? And size of data is, let's say size of data is 200 byte. bytes. So server will give acknowledgement on what acknowledgement number? Because it is TCP based, so definitely server will give acknowledgement. So here acknowledgement will be on what acknowledgement number?
201.
301.
301 or 201?
300. Sequence
in
number
Uh-huh.
300. It will give acknowledgement on 300, not
Yeah, yeah, yeah.
301.
Yeah,
While sending actual data, acknowledgement number will be sequence number plus size of
got it,
data.
got it.
Done.
Yes.
Again, let's say computer have sent one data whose size is again 200 byte, and this time sequence number will be 300, and let's say size of data is 200 byte. So server will give acknowledgement at what acknowledgement number?
So 300 plus 200, 500.
500. Very good. Acknowledgement will be 500. This is the sequence number and acknowledgement number in case of sending actual data. Done.
Yes.
Hope guys it is clear to everyone.
So I have a question.
Yes.
In previous example, you say sequence number plus 1.
Yes. Sequence number
So-
plus 1.
Plus 1. So here you just add sequence number plus bytes plus acknowledge number. You
Okay.
you just make it together, and there just you say
While
we need-
three-way handshake, see acknowledgement equal sequence number
Uh-huh.
plus 1.
One.
Here
Yes.
acknowledgement is
200
sequence
Uh,
number
100.
plus data size.
Okay.
This is getting my point. While sending actual data, acknowledgement will be sequence number plus size of data, and while three-way handshakes, acknowledgement will be sequence number plus 1. Done.
So I didn't see plus 1 in the second example. Sequence number plus 1. Where is sequence number plus 1?
Sequence number plus 1 is in case of three-way handshake,
Uh-huh.
and sequence number plus size of data is while
Got it.
sending actual data.
Got it.
Let's say I have one router over here. Done. And one more router 1 and router 2. You know there is one protocol called Telnet.
Yes.
What is the use of Telnet protocol? Telnet
Extended-
protocol is used to take remote access of networking devices.
Okay.
Let's say here I am using IP 10.1.1.1 and here my IP address is 10.1.1.2. Done. On
Yes.
router number 2 I have enabled Telnet. Telnet. Done. So now I can access router 2 from router number 1. I can access router 2 from router number 1 by running command telnet. After that IP address of router 2, that is 10.1.1.2. First,
So this
yes,
connection will be through Ethernet cable or through wireless.
yes, through Ethernet cable.
So then why we use a Telnet protocol? If you have like Ethernet
Let's say
cable,
R1 is router 1 is in different location and R2 is in different location. Through ISP you have reachability,
okay, got it. Okay.
right? So you cannot move there. So what you can do, you can take access. Suppose you need to modify the configuration of router 2. From router number 1 you can modify it if you have connectivity. Done.
Mhm. Yes.
And Telnet is the service which uses TCP at transport layer. So first router will send what? One SYN message. Then router 2 will send what? SYN plus ACK message.
Mhm.
Then again router 1 will send what? Acknowledgement message. Right?
Yes.
After that it will send actual Telnet message. Yes or no?
Yeah.
Router 1.
So till here we have like three-way handshake, right?
Yes. Till
Okay.
here we have three-way handshake. See, if you want to see the practically, I can show you practically as well, and that will be more clear to you. So let me open GNS3. Do you have guys? Do you guys have GNS3 or not in your computer?
No. We have only
EVNG
a packet tracer.
packet tracer you have only.
Yeah.
So please install this software as well. Otherwise, I have to install it in your computer,
Okay.
because here we can capture the link. In packet tracer, we cannot capture the link. Okay, just I am going to take one router over here and two router total, router 1 and router 2. See what I will do, before configuring telnet and taking remote access, I will capture the link between router 1 and router 2, so that all the traffic will be captured in the link, and I will show you the practically whatever things we have discussed here, not theoretically. Okay.
Okay.
So before capturing the link, just I am going to configure the IP address. Here I will configure IP 10.1.1.1. Here I will configure IP 10.1.1.2. Done. On this router we will enable telnet. Done.
Yes.
Okay. So first of all, I am going to configure the IP address. You know how to configure IP address on router interface?
Mhm.
Go to global config mode. After that interface F0/0 interface, say no sut. By default router interface is down, so I need to run no sut command every time.
Ac-
After that, yes,
Actually, like before you say like how to configure the router, but I don't know how to do it.
don't worry, we will discuss this also in upcoming time.
Okay.
Here I am configuring IP 10.1.1.1. Let's say you just consider that on router 1 this is the IP address. Okay, and on router number 2 I'm going to configure the IP address. Config T interface F0/0 no sut, and IP address is 10.1.1.2 I've configured IP address on both router. Now I am going to enable telnet over here. So line VTY 04 and password is, say no password, no login. Password is not required now. Done. Now I am capturing the link. See here on the link you can see the traffic. These are traffic on link. Done. Now what I am going to do, from router number 1 I am going to take telnet access. Say telnet and 10.1.1.2. Now you can see I have telnet access. Okay. Now this is actual data of telnet. These are actual data. But before sending actual data, are you able to see the SYN message?
No.
This one. SYN message. Here you are able to see this is SYN message.
Yes.
Who have sent it? 10.1.1.1 means router 1. Destination is 10.1.1.2 means to router 2. Router 1 have sent one SYN message to router 2. Yes or no?
Yes.
And sequence number is
0.
0. Here router 2 have sent what? 10.1.1.2 to 10.1.1.1 SYN plus ACK.
Acknowledge.
SYN plus ACK. Yes or no?
Yes.
Here also sequence number is 0 and acknowledgement number is
1.
1. After that 10.1 router 1 is sending what? Acknowledgement. Sequence number 1 and
1.
acknowledgement number is also what? 1. Getting my point?
Yes.
See what is happening. This is router 1. This is router 2. First this message, SYN message, router 1 have sent to router 2. SYN message. Sequence number is 1. Sorry, 0. Yes or no?
Yes.
And source port number is random port number and destination port number is 23. This is well known port number of telnet. Done.
Yes.
After that router 2 have sent what? SYN plus ACK. SYN plus ACK where sequence number is 0 and acknowledgement number is 1. Why acknowledgement number is 1? Because here sequence number is, you can see 0. 0 plus 1, that is 1. Yes or no?
Yes.
After that router 1 have sent acknowledgement. And sequence number is 1, acknowledgement number is 1. Because this is second message of router 1. So first message sequence number is 0. In second message sequence number is 1. And here acknowledgement number is also what? 1. Because here sequence number is 0. So 0 plus 1, acknowledgement number will be 1 over here. Done. This is while three-way handshake. Yes or no?
Yes.
Now see, while sending actual data, this is first message. This one. 10.1 have sent to 10.2. The telnet message. Actual traffic. Let me open this. And here I am opening TCP header. Source port is random port number, destination port is 23. Okay. Sequence number is what?
1.
1. And total size of data is what? 12 byte.
4 bytes.
So next sequence number will be what?
12 plus 1, 13.
Yes or no?
Oh, yeah.
Yes. And router 2 will give acknowledgement, and what acknowledgement number? See.
13.
Router 2 is sending acknowledgement on acknowledgement number what? 13. Means size of data plus sequence number. Sequence number is 1 and total size of data is 12 byte. So it is giving acknowledgement on 13. Yes or no?
Yes.
So this is how sequence number work while sending actual data. Is it clear, guys, to everyone?
Yes.
Yes.
Okay, like this it will send more data, more acknowledgement. These are the things here.
So,
Here our concern is not telnet. Our concern is understanding the sequence number and acknowledgement number only.
yeah. Okay, I have a question. Like when we do first time like sequence and acknowledge like three-way handshake, after that we can send data through, right? Then it doesn't
Yes.
need like a three-way handshake again.
No,
Okay.
until and unless this connection will not terminated, it will not perform three-way handshake, because see now there is one connection. So TCP brief. So sorry, enable. What we can do here, exit and so TCP brief. There is no any connection. So again, if you will say telnet 10.1.1.2, it will perform three-way handshake. Let me do one thing. Here I am going to configure one IP address, password, enable password 123. Done. That's it. Now I am going to take telnet 10.1.1.2. See, I have access of router 2, enable, password is 123, and so TCP brief. See, there is one TCP connection, yes or no?
Yes.
10.1.1.2 to 10.1.1.1. There is one TCP connection, state is established. So there is already a connection. So if the router 1 need to send telnet data directly, it will send the data until and unless this connection is there.
Okay.
Okay. Okay, guys.
Yes.
Is it clear to all?
Yes.
Abdul?
Yes.
Great. So in the book also we have same thing, sequence number, acknowledgement number. You can read book also. And data
I have a
encapsulation,
question.
decapsulation.
Is it important to learn this thing like sequence number or talent number or something?
Yes, it is important. Okay. Here also you can see at which layer? At application layer we call data to data. At transport layer, my data plus TCP header is known as segment. At network layer, actual data plus transport header plus IP header. At data link layer, actual data plus TCP header plus IP header plus data link header. Done?
Yes.
So these are the framework. See what we called it? Segment, what we called it? Packet, what we called it? Frame. Done? Now it is comparing OSI model and TCP IP model. Data encapsulation, data decapsulation, we had already discussed. To actual data we called payload at each layer. Like at transport layer, payload is data. At network layer, payload is segment. At data link layer, payload is packet. After that we have Ethernet LAN in the book. Okay. And if you want to see the TCP header, you know window size. What is windowing?
I don't know.
We had not discussed this.
No.
No.
Okay. See,
No.
windowing is a technique to reduce the number of acknowledgement. Guys, suppose this is computer and this is one server. Let's say this computer need to send 500 data. So it will send first data. After that server will give acknowledgement. Then it will send again next data. Then again server will send acknowledgement. Again it will send next data. Then it will send acknowledgement. Yes or no?
Yes.
Like this it will work. So if receiver means destination machine will send one acknowledgement after every data, then communication will be very slow. Yes or no?
Yes.
So that's why we come with windowing technique. Windowing technique is used to reduce the number of acknowledgement. While three-way handshake, both machine will decide their buffer memory, negotiate their buffer memory, and they will decide one window size. Let's say window size is 500 byte. Then if window size is 500 byte, means server will give acknowledgement after receiving 500 byte data. See, window size is 500. This is sender, this is receiver. It have sent, let's say, 100 byte of data. Again it have sent 100 byte of data. Again it have sent 100 byte of data without acknowledgement. Again it will send 100 byte of data without acknowledgement. Again it will send 100 byte of data without acknowledgement. So it's this computer have sent 500 byte of data. Now this computer will expect one acknowledgement from the server. So server will give one acknowledgement over here. Done. Again machine will send 500 byte of data. Then it will expect one acknowledgement like this. Done. So actually sender machine will receive acknowledgement after sending the data equivalent to window size. Done. And here also you can read, in windowing, both devices negotiate their buffer memory. The device will elect the least buffer memory as window size. A sender machine send data equivalent to window size and then expect acknowledgement. With the help of windowing, we also achieve flow control, and window is used to reduce the number of acknowledgement. Here are one example. MTU of this computer is 100 byte, MTU of this computer is 700 byte. MTU means maximum transfer unit. That means maximum data that a machine can transfer at a time. That is known as MTU. This computer can send 100 byte data from this port at a time. So this is MTU. And server can send 700 byte of data at a time from this interface. So that is MTU of server.
So I have a question here.
Yes.
So if I send 400 byte data from client to server, is it
Yes.
go through all 400 or they go by like 100, or I should send 100?
That will depends on MTU. Let's say this machine need to send 1000 byte of data.
Yes.
So it can send 100 byte of data at a time only. So it need to send how many packet?
10.
10 packet.
Oh.
And window size is what? Let's say 700 byte. So after sending 700 byte, it will expect one acknowledgement.
Got it. Okay.
1, 2, 3, 4, 5, 6, 7 acknowledgement.
Okay. Got it.
Done.
Yes.
After that we have network layer. So network layer provides logical address to the router. Router and layer 3 switch works at this layer, and the protocol which works at this layer is IP, EAGRP, OSPF, ICMP, and many more protocols are there. In upcoming day you will understand which works at layer 3. Okay.
Yes.
At data link layer, also you can read data link layer provides the physical address. At this layer, error detection is done. Switch and bridge works at this layer. This layer is responsible for forwarding data from one device to another device in a network. This is only layer in which header as well as trailer are added. And at this layer, protocols which work is ARP, SDLC, and etc. After that, physical layer. PDU at different layer. At application layer, we call data to data, then segment, packet, frame, bits. You already know encapsulation and decapsulation. Encapsulation means adding extra information with
What does
actual
it
data.
mean? What does it mean, PDU data? Can you go back? Yeah.
This one.
Yeah, PDU. Yep. What does it mean?
PDU means form of data at particular layer. Protocol data unit. PDU stands for protocol data unit. And this is nothing but the form of data. Like we have one HTTP data. So what we call at application layer? Data. At presentation layer? Data. At session layer? Data. But at transport layer we called it segment. Because at transport layer, data, and plus we have TCP or UDP header. So data plus TCP or UDP header is nothing but segment. Done. Done, guys.
Yes.
After that, encapsulation, decapsulation is also clear to you. Encapsulation means adding extra information with actual data. Decapsulation means removing extra information from actual data. These are not so important, but these are important point. You should keep in mind. You should learn once, right? If you will forget, no problem. But overview of each layer, like transport layer is responsible to provide source port, destination port. These are the important thing. After that, we have TCP IP model. So we have only 5 layer here, and see, this is TCP header. This is TCP header. In TCP header, there are source port number, and as you know, source port number is 16 bits information. Destination port number is also 16 bits information. Sequence number is 32 bits information. Acknowledgement number is 32 bits information. These all information will carry by TCP header. After that, header length. What is the size of header length? That will be the information inside the TCP header. After that, there are some reserve flag. So header length is 6 bits information. Reserve field is also 6 bit. Flag is also 6 bit. And window size is, header length is 4. And this one is 16 bits. Header length is 4 bits information. Reserve is 6 bit. But in new TCP header, 3 bits are reserve and 9 bits are for flag. Then there is one checksum field, 16 bits, and urgent field 16 bits, and option are there. Option is used for additional use. Don't think about this field. So these are important field in TCP header. This is TCP header. Okay, one TCP header carry this information. After that, UDP header. After that, you can read each field as well here. And UDP header. In UDP header, you can see there is only source port, destination port, header length, and checksum. And after that, your actual data. UDP header. Then we have IP header. This is my IP header. In IP header, first field is version. In this field, there will be information about IP version, IPv4 or IPv6. After that, again, header length. What is the size of header length? Then this is TOS. TOS is used for quality of service. After that, total length means data plus header length will be the total length. Identification, on a router router can perform fragmentation, means router can divide a data into a smaller part. Like, let me make you understand with one example. Here I have one router, R1, R2, and we have one server over here. And I have one computer over here. Let's say this router interface, this interface MTU is 100 byte only. By default, MTU size is 1500 byte on Cisco IOS. Here also 1500 byte. Okay, that means both router can transmit how many data? What is the size of data that router can transmit? 1500 byte. Let's say this computer have sent one data whose size is 2000 byte. 2000 byte. So what router will do? Router cannot forward 2000 byte data from this interface, yes or no?
Yes.
So router should drop it. But router will not drop it. Router have capability to divide this data into two parts, and that is nothing but fragmentation. Fragmentation. That is nothing but fragmentation. Segmentation means dividing large size of data at a smaller size of data at transport layer, and fragmentation means dividing large size of data into a smaller size of data at network layer. So router will divide 200 byte of data into two part, 1500 byte plus 500 byte. And here how router 2 will identify that both data belongs to a single segment. For that we have identification field in IP header. Here it will put identification number 1, identification number 2. Now router 2 can arrange it, yes or no,
Yes.
like this. So that's why we have identification field. And let's say I have one computer over here, one router over here, and one server over here. Let's say application layer have generate one data whose size is 2000 byte, and this is HTTP data. So HTTP uses what? TCP at transport layer. So at transport layer TCP will divide this data into two parts. But if we are using UDP, so UDP cannot divide the data, it can directly forward data to router, and then router need to perform fragmentation. But in case of TCP, while three-way handshake, sender and receiver will negotiate MSS, maximum segment size. What should be the size of one segment? So let's say size of one segment should be 1460 byte. This is the size of data plus 20 byte transport header plus 20 byte IP header. Total size of data is 1500 byte. Yes. So transport layer will divide this 2000 byte of data into two parts. First will be 1460 byte and next part will be 540 byte. Getting my point?
Yes.
So TCP have capability to divide large size of data into a smaller size of data, but UDP don't have. So for UDP data, router can perform what? Fragmentation. Done?
Yes.
So we have discussed two terms. One is segmentation and another one is fragmentation. Segmentation is dividing, both are dividing large size of data in a smaller part of data, but segmentation will done at transport layer, and fragmentation done at network layer. Segmentation will done with TCP and fragmentation will done with router. Router will perform fragmentation. Done. Now, so we have identification field for that. Then we have flag, fragmented, offset, TTL, time to live. We will discuss about this field. Then this field is important, protocol. You know, in IP header, see this field, time to live, very important field. Protocol field, very important field. Source IP address, very important field. Destination IP address, very important field. And then your actual data. These are the important field inside the IP header for CCNA. For CCNA only these fields are important. In TCP header, source port and destination port are important for CCNA student. Done. Done, guys.
Yes.
So at network layer,
Yes.
actually protocol field is used to identify the upper layer protocol. If in this field value will be 6, that means it is an traffic of TCP. If here protocol field will be 89, that means it is a traffic of EIGRP. So it is used to identify the upper layer protocol. Done.
Yes.
And time to live. Time to live is used for loop avoidance. Let's say in upcoming day you will understand while discussing router that how loop can form in the network. I have router 1, router 2. Let's say router 1 have sent one data to router 2 and router 2 have sent same data to router number 1. because of misconfiguration. Again, router will send same data to router 2. Again, it will send to router 1. This is what loop. You will understand in routing that how loop can form. Because of misconfiguration by network engineer, loop can form here. So for lifetime, traffic will be moving between router 1 and router 2. Yes or no?
Yes.
So that's why we have actually TTL filled in IP header. And once a packet cross router, TTL will decrement by 1. Getting my point?
Yes.
TTL value depends on operating system, right? In Cisco operating system, TTL value is 255. So router 1 will send packet with TTL what? 255. When router 2 will receive it, it will decrement TTL by 1 and then it will forward to router number 1. So TTL will become what? 254. When router 1 will forward it to router 2, TTL will become 253. Whenever a packet cross router, TTL decrement by 1.
What's
Yes,
TTL?
TTL time to live. Once TTL will become 0 on any router, that router will drop the packet. Router cannot process the packet with TTL value 0.
Okay.
So this is a mechanism for loop avoidance. Okay. And we have one separate field in IP header. We will discuss more about TTL in upcoming day. Done?
Okay.
This is IP header. After that, here are some information about the IP header you can read. Then segmentation and fragmentation, there are difference you can read. Dividing big size of data into a smaller part of data, it is done at transport layer, at layer 4, like these things, right?
Yeah.
After that, we have some application layer protocol, HTTP. So HTTP port number is 80. It uses TCP at transport layer and it is used to access web page from the web server. It is not secure protocol. HTTPS port number is 443. It uses TCP at transport layer and it is also used to access web page from the web server and it is an secure protocol. Done?
You said HTTPS is unsecure protocol?
HTTP is
Okay.
unsecure.
Okay. Yeah, got it.
This is not secure.
Yeah.
Okay. So these two are application layer protocol. Next application layer protocol is Telnet. Telnet port number is 23. Like this only you should remember the protocol. Okay. You need to remember these are very important, brother. Whatever things is important, I am telling you manually that this is important. Okay.
Okay.
So these are important. You need to learn all protocol, all these protocol uses what port number and what service at transport layer. Okay. So Telnet is uses port number 23. It uses TCP at transport layer and what is the use of Telnet protocol. So it is used to take remote access of networking devices and again it is not a secure protocol. It is not a secure protocol. So we have next protocol that is SSH. Port number is 22 and it uses TCP and it is also used to take remote access of networking device, but it is an secure protocol. In Telnet, your data will travel in plain text. Here in SSH, your data will travel in encrypted format. Done. After that, next protocol is FTP. FTP uses port number 20 and 21. It uses TCP service at transport layer. It is used to access file server from the file server. We can browse the file in FTP, but see, we have one more protocol that is TFTP. But difference is we cannot browse the file over here in TFTP, but we can browse the file in FTP. That's it. After that, port number and it uses UDP. So FTP uses TCP and TFTP uses UDP. And both are used to access file from the file server. Done. After that, NTP protocol, DHCP protocol. DHCP stands for Dynamic Host Configuration Protocol. Port number is 67 and 68. 67 is used by DHCP server and 68 is used by DHCP client. it uses UDP, Service and Transport Layer, and it is used to provide IP address, subnet mask, default gateway, DNS server IP address to the client automatically. We have two options to configure IP address on the client machine, manually and dynamically. So either we can use DHCP protocol, DHCP server, or we can configure manually. Done. After the DNS. So DNS is,
Excuse me, sir. DCP provide the IP addresses in DNS.
DNS, no, DHCP. Like, you know, if I will show you in my computer. See, on the Ethernet port, suppose I want to configure the IP address. Done. Go to property, then IPv4. And see, I have two options to configure IP address. One is use the following IP address manually, and another one is obtain an IP address automatically. Yes or no?
Yes.
So if I will click on it, open an IP address automatically, it will send request to DHCP server that please give me one IP address. Getting my point?
Got it. Yes. And then what's the DNS?
A DNS is used to resolve the domain name from, you know, is it possible to remember the IP address of each site? You know what is the IP address of facebook.com?
No.
You know what is the IP address of, yahoo.com?
No.
No. So it is not possible to remember the IP address of each website. Do you know what is the mobile number of, what is my mobile number?
Yes, I know.
You don't know. You have saved with my name, with PM, yes or no?
Yes.
Why you have saved? Because remembering name is easy. Remembering number is hard. Yes or no?
Yes.
You can remember my number. You can remember my name. So that's why you have one phone book or contact book in your mobile. Through that you can save a number with name. Yes or no?
Yes.
So DNS is also like that. DNS is a server which store all domain name with IP address. Let's say domain name is www.pmnetworking.com. Whose IP address is, let's say, 1.1.1.1. So DNS have one entry over here. So if someone will ask to DNS that, hey DNS, can you tell me what is the IP address of pmnetworking.com? DNS will say, yes, IP address of PM networking is 1.1.1, and then machine can send request to 1.1.1.
Okay. So how do I know like my computer has a DHCP server, or how can I know?
You have to provide the IP address of DNS server. You know,
No.
here if I am typing in my browser www.google.com,
About DHCP.
yeah, DHCP server will provide the DNS IP address.
Like how do I know like my computer have DHCP server or they don't have it? How like?
How, sorry brother, I didn't get you.
Oh, okay. So how do I know like do I have a DHCP server in my computer or I don't have it?
So if you are connected with internet, it depends on your ISP now.
Okay.
Let's say you have internet connectivity from XYZ ISP.
Uh-huh.
So that ISP have DHCP server in their network.
Got it.
So if I am typing www.google.com, actually my machine cannot send request to google.com directly. My machine need IP address of google.com.
It needs
So it will-
from the ISP, right?
Yes.
Okay, got it.
My machine will look up for the DNS IP address first. CMD, it will check IP config all, and it will find what is the DNS IP address.
Yeah. 192.168.1.1.
DNS server 192.168.1.1. Yes or no?
Yes.
So it will send request to this server that please give me the IP address of www.google.com. Then DNS server will provide the IP address. Then it will send the actual data.
Okay.
Okay.
This everything will done through the internet, right? If I don't have internet,
Yes.
it doesn't work.
Definitely.
Okay.
or directly I can type the IP address of google.com here. If I know the IP address, then my machine will not send request to DNS server if you are providing the IP address directly.
Okay, got it.
Okay.
Yes.
So where is, so DNS server, let me show you the practical of this thing once. First of all, in any packet, let me open any telnet traffic. See guys, how many layer are there in traffic? This is actual traffic, telnet traffic. This is at application layer. After that, transport layer, then network layer, then data link layer, and then physical layer. We have how many layer? 5 layers, because we are using what? TCP IP model. That's why we have only 5 layer na.
Yes.
At application layer, this is my actual data, yes or no?
Yes.
After that, at transport layer, which protocol is running? TCP, transmission control protocol.
Yes.
Because telnet is an TCP based service, yes or no?
Yes.
Source port number is
Unknown.
random port number, and destination port number is 23, which I told you the port number of telnet is,
23.
where is 23? Yes or no?
Yes.
Done. After that, in IP header, are you able to choose source IP and destination IP?
Yes.
And if you will expand the IP header, are you able to see the protocol field?
Yes. TCP.
Protocol number is 6. 6 is protocol number of TCP. And TTL is
TTL
225.
255.
Yes, 255. Done. This is IP header, and after that Ethernet header, source MAC and destination MAC. Source MAC is the MAC address of router 1, destination MAC is the MAC address of router 2. And in Ethernet header there is one field called type field, and in type field there is information about IPv4. So see, first of all brother, first of all, when router 2 will receive this data, router will receive at which layer? At this layer, at physical layer, yes or no?
Yes.
It will check what? It will actually, it will hand over the data to Ethernet header, yes or no?
Yes.
Ethernet header will check what? Destination MAC address. So destination MAC address is mine or not? If destination MAC address is mine, then only I will accept this data. So what is the MAC address of router 2? Here we can verify that MAC address of router 2. So interface, so yes, interface F0/0 include bytes. See, this is the MAC address of router 2. Is both MAC address same or not?
Yes.
Yes. So it have accept the traffic, but data link layer should have knowledge about the upper layer protocol, that okay, this is for me, traffic, this frame is for me, but to whom I need to hand over it? For that it will check what? Type field. It will check type field, and type field value is 0x800, 0x0800. That means this is type code of IPv4. It will remove Ethernet header, means source MAC, destination MAC, these things, and it will hand over the actual packet to
Transmission level.
IP protocol, to network layer. Network layer will check what? Destination. Destination is 10.1.1.2. Oh, this is for me, because destination IP address is mine IP address. See, so IP interface brief. My IP address is 10.1.1.2. Okay. So destination is 10.1.1.2. Okay, this is for me, but to whom I need to hand over this packet? For that it will check what? Protocol field. In protocol field value is what? 6. So it will hand over actual segment to what? Transport layer. It will remove the layer 3 header and it will hand over the segment to transport layer. Transport layer will check what? Destination port number. Destination port number is what? 23. Okay. Someone have sent the telnet traffic. Let me check the telnet is running on me or not. Yes, telnet is running on me. Okay, let me hand over the actual data to telnet. Like this, router 2 will process the data. Okay,
Yes.
done. Now I am going to show you some application layer protocol. We have time now. How much time we have for today's session, brother?
I think we have enough time.
Enough time, then I will start this practical tomorrow.
I have a question, not about this class. What's the earlier time we can start a class?
I can start at any time. You decide when you are comfortable. I don't have
Okay.
problem.
How about you guys?
So I can't take early class because I come to work. I came from home at 9 o'clock, 9:15 around, and I will get to work about 10, something like that.
Yeah, it's a little bit late for me because I just come back from work. I'm kind of tired. Okay, we're gonna talk about it later, and then we will let you know. Yeah, please
Yeah, yeah,
continue the
yeah.
class. Okay, thank you.